All right. I should be live now, I believe. Let me make sure that I'm live. Da-da-da-da-da. Okay. I'm not sure why this is not working, but let's see. Okay, it's working. Okay, we are going to do the April 2017 calculator section. I'm going to go through this, explain my thought process and some questions, and yeah, hopefully you guys get something out of it. All right. Let's start in 3, 2, 1. Timer's going. Let's go. All right. M equals 3. How much greater is 10m than 6m? Okay, well, 10m is going to be 30 because that's 30 times 3. And then 6m is going to be 18. So it's 12 greater. The temperature in degrees Celsius of a hot object placed in a room is recorded every 5 minutes. The temperature of the object decreases rapidly at first, okay? Then decreases more slowly as the object's temperature approaches the temperature of the room, which the following graphs could represent. This is increasing, not decreasing. This is also increasing. This is the answer, because look at this. It's decreasing, and then it slowly kind of tapers off a little bit. So it's going to be A. Number 3. Which of the following values of x is a solution to the equation above? I'm going to go ahead and square both sides. Actually, no, I'm not going to do that. Let's go the quick route. Let's just plug in. So negative 1 minus 2 is going to be negative, well, I know negative 1's out because that's going to be a negative number, and you can't take a square root of the square root of something cannot equal a negative number, so it's not going to be negative 1. If I plug in 1, that's the same deal that we're dealing with. 4 minus 2, this one's probably going to be the answer. So 2 equals root 16. Oh, that's not the answer. So the answer might be 6 here. Yeah. 6 is the answer. Because 6 minus 2 is 4, which is equal to root 16. Awesome. Last year, 800 students attended the career fair at West High School. This year, the number of students who attended the career fair increased by 5%. How many students attended, at West High School? So just increase 800 by 5%. We can do that by multiplying by 1.05. We have that 1 there because we're increasing. So let's do 8 times 1.05 in the calculator, and we get 8.4 or 840. Oh, well, it should be 840, but I forgot to do 800. I don't know why I did 8. 800 times 1.05. Yep, 840. Awesome. Okay. Nutritional information for 1 ounce servings of seeds and nuts. The table above shows these calories in grams of fat and grams of protein in 1 ounce servings of selected seeds and nuts. Okay. How many more grams of protein are in 1 pound of pumpkin seeds that are in 1 pound of pistachios? Okay, so the table above shows the calories, grams of fat, and grams of protein, okay, in 1 ounce servings. Got it, okay. 1 pound of pumpkin seeds, so that's 16. Okay, so we're looking at pumpkin seeds and we're looking at the protein, right? So 8.5, and then that's in 1 ounce. So we need to multiply that by 16 to get the, for 1 pound. So 8.5 times 16 times 16, and that's going to be 136. Cool. And then it says how many more are in pound of pumpkin seeds than a pound of pistachios. So pistachios has 3.0 times 16 would be 48. So 136 minus 48 is going to be our answer, because we want the difference between these two, which is 88, option C. Lionel purchases 1 pound bags of each of the 5 seeds and nuts shown in the table. Of the following, which best approximates the average, the arithmetic mean of calories per bag? Okay, so 1 pound bags of each of the 5 seeds. Okay, so 1 pound bag of all of these, and we are worried about the calories, so let's highlight. All right, so we know we're going to have 16 times 189 plus 80. Okay, I see what we're going to do. So we're going to do 16 because we're doing pounds. And then the first number is going to be 198 and then 80. 198 plus 80 plus 159, I think I saw. Yep, and then 166, 185. 166, 185. And then I'm going to go ahead and divide by the number of, I guess, things that he bought. The number of bags. So he bought 1, 2, 3, 4, 5 bags. So I'm going to divide by 5. And that should give me the arithmetic mean. So let's do it in the calculator real quick. So 198 plus 80 plus 159 plus 159 plus 166 plus 185. 788 times 16. And we're going to divide this by 5. So 2521. Which is the best approximates? So it's going to be about 2,500. Which makes sense. All right, a pool initially contains this many cubic feet of water. A pump begins emptying the water at a constant rate of 20 cubic feet per minute. Which of the following functions best approximates the volume in cubic feet of water in the pool? T minutes after pumping that begins for 0. T is between 0 and 69. Okay. So initially 1385. So we know that's going to be our y-intercept, right? And then our slope is going to be a negative because it's emptying 20 t. So I would definitely say the answer here is A. All right. At a snack bar, each medium drink costs $1.85. Okay, so sure. Each large drink costs C more dollars than a medium drink. So medium equals $1.85, and then a large drink, or L, is going to equal C plus $1.85. If 5 medium drinks and 5 large drinks, so 5 medium drinks and 5 large drinks, cost a total of $2.50, or $20.50, sorry. What is the value of C? So now we have our system of equations, and we can solve pretty easily. We want the value of C here. So let's go ahead and plug in Okay, let's go ahead and plug in 185 for M. So we get 5 times 185 plus 5L equals 2050. Okay. 5 times 1.85, let's see what that is in the calculator. 5 times 1.85 is 9.25, so 9, so, and then I'm going to do 2050 minus that. Okay, so I'm going to do 2050, 20.5 minus our answer there. And I get 11.25, so it's going to be 11.25 equals 5L. And then from here, I'm just going to divide by 5 to get L. So divide by 5, and that's going to be 2.25. 2.25, and we want the value of C, because L is equal to C plus 185. So that means that we can subtract 185, because 225 is L, right? So we can plug that in. So we get 2.25 equals C plus 185. So if we subtract 185, subtract 1.85 on both sides, we should get the value of C, minus 1.85. And that's going to give us 0.4. So option B. Kate bought a bus pass at an initial value of $90. Okay. For every bus ride Kate takes, Okay. $1.80. The cost of one bus ride is subtracted from the value of the pass. What percent of the initial value of Kate's bus pass is the cost of one bus ride? Okay, so we're just going to do 1.8 divided by 90. Kind of weird, but sure, we'll do that. To find the percent, 1.8 divided by 90. So it's 2%. 2%. All right. To determine whether residents of a community would vote in favor of a ballot proposal to use $100,000 of local taxes for additional playground equipment in community park, Jennifer surveyed 60 adults visiting the park with their children during 1 week in June. She found that 45 of those surveyed reported that they would vote in favor of the proposal. Which of the following statements must be true? Of a ballot proposal to use $100,000 for additional playground equipment. Okay, and then she goes to a playground. Okay. When the actual vote is taken, 75% of the votes, that's not necessarily true. No prediction should be made because the sample size is too small. I agree. Ooh, actually. I think the sampling method is not flawed. Okay, it's definitely flawed. No prediction should be made because the sample size is too small. I don't think that's necessarily the thing. I think it's C. The sampling method is flawed and produce biased results because you're asking people at a playground. Obviously, they're going to say yes, and all the answers are going to be yes. All right, if x to the fourth minus y to the fourth equals negative 15 and this equals this, what is the value of this of this? Okay, we're going to do a difference of squares here. Difference of squares looks like a squared minus b squared equals a plus b times a minus b, okay? I'm going to do that with this here. So it's going to look like x to the fourth minus y to the fourth is equal to x squared minus y squared times x squared plus y squared. That's a difference of squares. Now, they said that x squared minus y squared is negative 3. So I'm going to get negative 3 in there. This is still x squared plus y squared. And then x to the fourth minus y to the fourth is negative 15. So if we divide by negative 3, we get 5 equals x squared plus y squared, which is what we're looking for. So say. Okay, question 12 and 13 refer to the following information. A cable company, okay, whatever. Which of the following is closest to the equation of the line of best fit shown? So we have a y-intercept of about 54. So I would definitely say it's C. Yeah. Definitely C. Yeah, I don't know why they had these other answer choices. Which of the following is the best interpretation of the slope of the line? Okay, so the number of years since, so the slope of the line is going to be the change in y over the change in x, right? So the change in y here is the percentage of households with cable television. So basically the slope just represents the average change in percentage of households with television every year, each additional year, I guess. The actual increase in the percentage each year could be this, the predicted increase, the actual increase in the number, the predicted increase in the number. Well, it's not going to be the actual increase, it's the predicted, right? Because it's the line of best fit. It's not exact, but it's pretty close. So it's not going to be actual, it's not going to be actual. Percentage, so it's B. A greenhouse owner purchases fertilizer in 60-gallon drums. The fertilizer is mixed with water to make several batches of solution. Each batch of solution is made by mixing 3 quarts of fertilizer with water. What is the maximum number of batches of solution that can be made from one 60-gallon drum of fertilizer? All right. Let's take this in. A greenhouse owner purchases fertilizer in 60-gallon drums. Okay. The fertilizer is mixed with water to make several batches of solution. So you need 3 quarts of fertilizer with water. What is the maximum number of batches of solution from 1 60-gallon? Okay, so 1 gallon is 4 quarts, which means that 60 gallons is 240 quarts. So if we divide 240 quarts by the 3 quarts of fertilizer for each one, we're going to get 80. Should be C. All right, distance from Tara's home. Tara rode her bicycle along a straight road from her home to a restaurant and ate lunch. She then continued along the way to a movie theater to see a movie. Finally, she returned home on the same road after the movie. Tara's distance from the home during the 4 hours she was out is shown in the graph above. How many total miles did she ride her bicycle? Distance from home. So how many miles did she ride? So she rode 3 here, right? 3. She didn't ride anything this way. She's not riding here, right? She's not moving because her distance isn't really changing. Just time is going by. Then she rides an additional 2 miles here. She's not riding on the flats again. And then she rides 5 miles back. So she rode 10 miles in total. Ryan has 1,500 yards of yards of yarn. He wants to knit at least 2 scarves and at least 3 hats. Okay, so at least 2. Okay, so each scarf is 300 yards of yarn. So 300 per scarf. And 120 for hat. 120 for hat. And he has 1,500 yards, so we can't use any more. So this has to be less than or equal to 1,500. At least 2 scarves, so S must be greater than or equal to 2. And at least 3 hats, so hats must be greater than or equal to 3. This is our answer, wherever it may be. It's not this, it's not this, it's not this, it's got to be this. Yeah. All right, Michael performed an experiment where he tossed 2 coins, 1 dime and a nickel, at the same time and recorded whether each one landed on heads or tails. The results are shown in the table above. For what percentage of the tosses did the dime Michael tossed land on heads? So dime on heads. Dime landed on heads 27 times. Of the tosses. So what percentage of the tosses? So now we need we need the total of all the tosses, right? So let's total these up in the calculator real quick. So we got 27 plus 24. We could do it by head, but mental math. 26 plus 23. Save ourselves the trouble. 100. Oh, no. Huh. That's not good. For what percent of the tosses did the dime Michael tossed land on heads? — 27, 24, 26, and 23. Each one, his results. Wow. That's really weird. Maybe I'm not seeing something. Hold on. So Michael performed an experiment where he tossed 2 coins. Okay, a dime and a nickel, I agree. At the same time, and recorded whether each one landed on heads or tails. His results are shown in the table below. For what percent of the tosses did the dime Michael tossed land on heads? Well, for what percent of the tosses? I think they're just talking about the dime then. So, okay, that's fine. So it landed on heads 27 out of, and then 27 plus 24 is, let's see, 40, 51, I want to say. Yeah. 27 over 51. I think that's what they want. So let's do 27 divided by 51. 52% about. 529, so about 53. All right. That was a little confusing question, but they wrote it weird. During a storm, the atmospheric pressure in a certain location fell at a constant rate of 3.4 millibars per hour over a 24-hour time period. Which of the following is closest to the drop in atmospheric pressure in millimeters of mercury over the course of 5 hours during the... Okay. Wow. Over the course of 5 hours. So, constant rate of 3.4 millibars per hour. So for 5 hours, it would be 3.4 times 5, right? That makes sense. 3.4 times 5. 17 millibars over 5 hours. And we want this in mmHg. So we can just convert, right? 17 MB right? 17 MB times, and then we're going to use some dimensional analysis. So 10, 13 MB. We want our units to cancel. That's why we're putting MB on the bottom, because we want to be left with mmHg, millimeters of mercury. Cancel. So 17 times 760. 17 times 760 is this. And then we're going to divide this by 1013. 1013. About 12.75 or 12.8. On its opening day, a car dealership had an inventory of 29 cars. During the first 6 months, 18 additional cars were purchased in the dealership each week, and the sales team sold an average of 15 cars per week during the first 6 months. Which of the following equations best models the car inventory? Okay, so on its opening day had 29 cars, so the y-intercept has to be 29. Okay. During the first 6 months, 18 additional cars were purchased by the dealership each week, and the sales team... weeks? Oh, man. I don't like that. 18 additional cars were purchased by the dealership each week. Okay. And the sales team sold an average of 15 cars per week. During the first 6 months, which of the following equation best models the car inventory at the dealership T weeks after opening day? Oh. Huh. Oh. Okay. Well, a car dealership had an inventory of 20. So we start with 29 cars. Okay. So that's our y-intercept regardless. So we start with 29 cars. 18 additional cars were purchased. So we're getting 18, but also losing 15 every week. So that's going to be 3, right? 3t, which makes sense. I like that. C equals 3t plus 29. Yep. That looks good to me. If 2 root x equals a, what is that in terms of a? Wait, what is 2x in terms? So we're going to square both sides. So I get 4 times 2x is equal to a squared. If I divide by 4, I get 2x equals a squared over 4. Okay, oh no, not this kind of stuff. We're only on problem 21. We have 30 minutes. Okay, we're okay. A project coordinator at a banquet hall is given the task of arranging seating for an award ceremony. The figure above shows the first 3 possible arrangements of tables and the maximum number of seats in each arrangement. If the number of seats in each successive arrangement is increased by 6 over the preceding arrangement, which of the following represents the maximum number of seats around n tables? I'm going to go ahead and plug in. I think that's the easiest one. So the maximum number of seats for arrangement 1 is going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. This has to be, I'm just going to make sure, but this has to be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yep. And then this is going to have to go to 20 because it's by 6 every time, right? So when I plug in 3 for n, I should get 20. So this gives me 18. 3 for n here is 9, plus 1 is 10, 2. I like this. N plus 1 is... Ooh, wait. Yeah, okay. 3 plus 1 is 4. 6 times 4 is not 20. 6 times 3 plus 3 is 6 times 6 is 36. I'm going to go with B. Because when I plug in 3 tables for n, I get the maximum number of seats, which is 20 for that table. The graphs in the xy plane of the following quadratic equations each have x-intercepts of -2 and 4. Wait, what? The graphs in the xy plane of the following quadratic equations? Okay, have x-intercepts of -2 and 4. The graph of which equation has its vertex furthest from the x-axis? So the graph of which equation has its vertex farthest from the x-axis? Has its vertex furthest from the x-axis? Okay. Wow, this is going to be a tough problem. problem, but I think what we can do is I'm just going to distribute each one. It's going to suck, but it is what it is. So x squared, and then that's like this, and then it's going to be plus 2x, and then, oh wait, hold on. So, oh man, this is a bad problem. So it's going to be like this. So we get x squared minus 4x plus 2x minus 8. So minus 2x plus 8. Minus 8. And then that's times negative 7. So negative 7 minus, or plus 28x. I'm just multiplying the whole thing by 7. And then, or negative 7, sorry. And then 8 times 7 is 56. So this is going to become plus 56. So this is the first one distributed. I just distributed everything, right? So there's nothing nothing crazy. This equals this. I'm going to do the same thing here. So I got, let's see. Oh, I should just, oh yeah, I should do that. I should just remember. Okay. So it's going to be x squared again, and then we said plus 2x minus 4x, which is minus 2x, and then minus 8. And we're going to do times 1/10 here. We're going to multiply this by 1/10. So if we do that, we get 1/10 x squared minus 1/5 x minus 8 over 10. Sure. This problem's going to take a long time. And then this one's going to be, what's this? Negative 1/2. So negative 1/2 x squared plus x, and then plus 4. Yeah. Okay. And this one's going to equal 5x squared minus 10x minus 40. Now, which equation has its vertex farthest from the x-axis? All we need to do is negative b over 2a for each of these, because negative b over 2a is going to be the x value of the vertex. So negative 28 over 2 times a, which is negative 14, which is going to be 2. So that's x equals 2. This one is going to be negative b, which is 1/5 over 2 times 1/10. So 1/5 over 1/5, which is just 1. Oh, yeah, 1/5 over 1/5, which is 1. Okay. So this one's b is out off the bat, because it's 1 is already further than 2. And then this one, negative b, so negative 1 over 2 times negative 1/2. So that's going to be negative 1 over negative 1, which again is just 1. So this is out as well. And then for this one, if we do negative b, we get 10 over 10, which is bad. So it's a. Oh. All right, the system of equations above C is a constant. For what value of C will there be no solution to the system of equations? So negative 2/3, which is the slope of this line, right, has to be equal to negative 4 over C. So negative 2C is going to equal negative 12. If I divide by negative 2, I get C equals 6. They have to have the same slope for no solutions. The polynomial blah, blah, blah can be written as blah, blah, blah. What are the roots of the polynomial? What are all of the roots of the polynomial? Youch. So definitely negative 2. Negative 2. Okay, so and p squared minus 1 equals 0. So if we add over 1, right, we get p squared equals 1. And then if we square root, we get p equals plus or minus 1. So I would say negative 1, 1, and negative 2. Yeah. Which of the following describes an exponential relationship between the pair of variables listed? So, okay. Ooh, this is very exponential. Nope, this is constant, not exponential. It says constant. This is also constant. Depth of D Yeah, this is also constant. It literally says constant rate. Exponentials are not constant, and we can see that by a percentage, because if you increase by a percentage, it's going to just get larger and larger, compound interest kind of thing. How much time do we have? 26 minutes, and we are on question 26. Not bad. A researcher is investigating the relationship between the price of a 4-pack of AA batteries at a convenience store and the number of companies a store has. She defines a store's competitor as another similar store within a mile radius of the store she selects. She selects 32 convenience stores across the state at random, and for each store, she records the number of its competitors and its price of a 4-pack of AA batteries. The results are shown along with the line of best fit in the scatter plot below. Another convenience store in the same state sells a 4-pack of AA batteries for $4.89. If the store's price is more than the predicted by the line of best fit, what is the least number of competitors a store could have? Wow, that was a really, really confusing problem. Let me read it real quick. Okay. So we can see that the price of dollars is the y-axis, number of competitors, sure. Another convenience store in the same state sells a pack of AA batteries for $4.89. So AA batteries for like $4.89, which would be like around here, or something like this, I'm guessing. If the store's price is more than that predicted by the line of best fit, so more than that predicted by the line of best fit, so like around here or something. Right. Something like that, I guess. One of those two. What is the least number of competitors the store could have? Okay. That's really interesting. So for $4.89, man. The store's price is more than that predicted by the line of best fit. Is more than that predicted by the line of best fit? I don't get it. Oof. This question is weird, man. I really don't know what it's asking. Okay, I'll just go for this. Line of best fit passes through the point 18, negative 12, or negative point 12. Which of the following can be concluded? Line of best fit will not model the price for a store with a large number of competitors. Yes, I think. Actually, no. Oh. Yeah, it will not model a store. A convenience store with 817 can no longer sell 4-packs. Well, they can. A convenience store with 17 cannot decrease its price any further. I think it's A. Yeah, I'm going to get A there. And then I'm going to come back to 26 because I just don't know what it's asking me. It's kind of a weird problem, but whatever. Right now we are at 22 minutes, so we're okay right now. Figure above shows that the shaded triangular region with hypotenuse of 5 centimeters, okay, has been removed from a rectangular tile with dimensions x by y. Okay. Wait, hold on. The figure above shows that the shaded triangular region with a hypotenuse of 5. Oh, so this right here. The shaded, right? This also has to be a right angle, by the way. Which of the following, which best approximates the area of the tile before the piece was removed? So we need to find the area of this tile, basically. Well, it's interesting. Of the following, which best approximates the area of the tile before the piece was removed? So we want y and we want x, basically. Okay. Well. Man, this is weird. That's 30 degrees. Okay. Huh. Okay, well, I'm going to assume this is 5 and this is 5. Yeah. And then I'm going to say that well, this is the adjacent and that's the opposite. So I'm going to say that the tangent of 30 here is equal to the opposite side, which is 5, over x. Right? Actually, no. Hold on. I'm not going to say that. I'm not going to assume that these are 5. There's no reason to assume here. We don't need to assume, I don't think. We know we're going to have to find this triangle anyways. The area. And subtract it from whatever. The main thing. So, what I'm saying is that we can say, okay, well, we can just do tangent on this one, right? So, I don't know. Let's call this like z or something. And say... Well, actually, I don't know. I guess we could, yeah, whatever. Okay, whatever. So the tangent of 30 here is going to equal the opposite over adjacent, so 5 over z, I guess. So, let's see tangent of 30. We know tangent of 30, I think, right? Is it easy? No, we don't know tangent 30. This is bad. Okay. Let us multiply over z. So we get z tan 30 is equal to 5. And then I'm going to divide by tan 30. So z is equal to 5 over tan 30. Let's see if this works. 5 divided by... Man, that's bad. That is really bad. Tile before the piece was removed. It would be this problem. I guess we'll come back to it. Why are there so many weird shapes? I swear. Circle of radius 10 that passes through the origin graphed in the xy plane. So passes through the origin. So 25 plus 25 does not equal 10. So these are out. Because it has to, when you plug in 0 for y and 0 for x, it should give you this. So C works. I don't know what this is though. Yeah, I guess this works as well. So these are both in. Radius 10 that passes through the origin and graphed in the xy plane. Well, if you plug 0 in here, we get negative 5 root 2 squared, so that's 25 times 2 plus, and then again 25 times 2, 50 plus 50. Okay. So these two both work, or no? With radius 10 that passes through the origin, so okay. Which of the following equations describes a circle with radius 10 that passes through the origin when graphed in the xy plane? Huh. Man, they're really throwing some tough ones at us. Let me think here. Which of the following equations describes a circle with radius 10 that passes through the origin when graphed in the xy plane? Okay. So it passes through the origin. Are they saying the radius passes through the origin? Like, I just don't get it. If so, it would be C. right, because there's a point 10, 10, which is the center. I could graph, technically, because this is calculator section. So I definitely could graph. I'm going to go ahead and graph. I am allowed to graph. I don't have a graphing calculator, but this is basically a graphing calculator. See, graphing calculator. So this is technically allowed. Let's try the first one. Plus y minus 10. And you can do this in your own calculator as well if you'd wanted to on the actual test. This one does not pass through the origin. That's interesting. So how come when I plug in 0, 0... Oh, yeah, what? That was stupid. It's going to be 100 plus 100 equals 100. Yeah, I don't know what I was thinking. It's D. 100%. Okay. That's all I needed to know. Yeah, I kind of fluked that one up. That's fine. That was a little fluke. In the xy plane, the graph of x minus 6 squared plus 3 is the image of the graph after a translation of how many units to the right? Ooh, well, so the vertex here is going to be 6, 3 on the first one. And then, so x plus 5 plus 3 is negative 5, 3. So we went, how many units to the right? We went 11 units to the right. Because from 5 to negative 6, or negative 5 to 6, it's 11. When 9 is decreased by 3x, or 9 is increased by 3x, sorry, the result is greater than 36. So greater than 36. Least possible integer value for x. I don't know. If we subtract 9, we get 27 equals 3x divided by, or sorry, not is equal, sorry, is less, is greater than, or less than, sorry. Yeah, okay. Divide by 3, so 9. Or no, x is greater than 9. So x is greater than 9. We know that. What is the least possible integer value? So then it's 10, because that's the next number. That's the least number that's greater than 9. And that makes sense, because if we plug in 10, we get 30 plus 9. Yep, very, very true. 10 is the answer. The table above shows the distribution of United States presidents according to the century and region of the country which they were born. Based on the information in the table, what fraction of the presidents who were not born in the 19th century? So who are not born in the 19th century. So that's going to be... That's 5 plus 9 plus 3 plus 3. So 6 plus 5 is 11 plus 9 is 20. So there's 20 total. Who are not born in the 19th century. We're born in the South. So born in the South were... Oh, wait. I didn't see those 2s down there. Hold on. Okay. So 18th and 19th century combined, we have 14 plus 6 plus 2. 6 plus 4 is 10. So that's going to be 24. So the total 24 presidents not born in the 19th century. And then in the South, specifically, we have 9 plus 3, which is 12, over 24, which is 1/2. So 50%. What fraction? 1/2. Yeah. If x does not equal negative 1, then what is the value of this? So if x does not equal negative 1. Huh. Well, that's pretty interesting. So let's go ahead and do that. So we get 2 plus 2x over x plus 1. So that's the same thing as saying 2 over x plus 1 plus 2x over x plus 1, which is the same as 2 over x plus 2, I guess, plus 2 plus 2x, so 4 plus 2 . What? I don't get it. 2. I don't know what's going on. This is bad. This isn't good. If x does not equal, it's like I feel like I'm just missing something on every problem. What is the value of 1 over x plus 1? Okay. If x does not equal -1. 2, so we get third, right? 2 plus 2x, so 2 plus 6, 8. 8 over 3, okay. What if we do 4? Or no, 3. Two plus 6, no, yeah. Huh, this is really weird. If x does not equal -1, okay, sure, x cannot equal -1. What is the value of okay. Moving on, I guess. I don't know. We might have to come back to that one. We have to come back to a lot of them. Let's try this one. Thomas is making a sign in the shape of a rectangular hexagon with 4 inch sides. He will cut out from a rectangular sheet of metal as shown in the figure above. What is the sum of the areas of 4 triangles that will be removed from the thing? Okay. Okay. Whatever. These weird triangles. Hexagon with 4 inch sides. So these are all. Oh no, that's 4. Okay. What is the sum of the areas that will be removed from the triangle? Well, if I split this up like this and like this, I get some equivalent triangles. You see that? I don't get that though. This is still 4. Oh, well, okay, they all have sides of 4. I see. So the hexagon has sides of 4. So this is 4, this is 4, this is 4, and this is 4, and this is 4. Okay. So the area of the triangles is just base times height. So if this is a 30, 60, 90, by the way. This is 30, 60. Which means it is 2x. So x, 2x. So this is 2. And this is 2 root 3 right there. Okay. And then what we're going to do now is we need the area, which is base times height. So 4 root 3 times 1/2, which is 2 root 3. And then we have 4 of those triangles, so it's going to be 8 root 3. Okay. 35. How much time? 7 minutes. No, that's not good. Okay. The price of a ticket to play is based on the row of seated, as shown in the table above. A group wants to purchase 10 tickets for the play. Okay. They will purchase 3 tickets for seat in row 1. 2 tickets for the seat in row 3, and 3 tickets for seats in row 12. What is the average ticket price in dollars for the 10 tickets? What is the average ticket price in dollars for the 10 tickets? Okay, so we're going to do 25 plus 25 plus 25, that's 3, and then plus 40, which is the 2 here, and then plus 45. So, yeah, 75 plus 40 plus 45. 75 plus 40 plus 45. And then 116, we're going to divide that by the number of tickets, which is 3 plus 2. Oh, wait. No. So they will purchase 2 tickets from seat and 2 in row 4, which means it's 2 times 2. So then there's another 20. We need to add 40 to this, so that's 200. Okay. So 200 divided by, and then the total, which is 3 plus 2, 5, 7, 10, which is 20. The average is 20. Man. All right. A fashion buyer for a large retail store purchased 315 items directly from the manufacturer for a total of $6,000. Okay. Some of the items were dresses purchased for $25 each, and the rest were shirts purchased for $10 each. How many more dresses than shirts did the buyer purchase? So, dresses plus shirts is equal to 315. items, right? 25 for the dresses plus $10 for the shirts is going to equal 6,000. And then it's just a, we got to solve basically. So let's go ahead and do that. D is equal to 315 minus S. So 25 times 315 minus S is plus 10S. And then that's going to be 25 times 315. Okay, so minus 25S. And then 25 times 315. Ooh. 7875 plus 10s, so this is going to become negative 15s, and that's going to equal 6,000. I'm going to subtract 6,000 minus the answer, so 6,000 minus the answer, and that's going to give me that, and I'm going to divide this by 15. Should give me 125. So there's 125 shirts. Equals S. So now if we plug that in, so 125. So 125 is S, so 125. So 315 minus 125. So 315 minus 125 is going to be 190. So there's 190 D, which is dresses or whatever. So 190 minus 125 is going to give us the answer for the difference. 65. Okay. 4 minutes. Wow. If the radius of each tire on Maria's car is 0.3 meters, what is the approximate speed of Maria's car to the nearest kilometer per hour when the instrument is showing that many revolutions per minute? Oh, man. If the radius of each tire is 0.3 meter, okay, what is the approximate speed of Maria's car to the nearest kilometer per hour when the instrument is showing 779 revolutions per minute? Well, 1 kilometer is 1,000 meters. That doesn't help. Well, it kind of does. Okay, that's fine. So 0.3 meter, we need to find the circumference, which is just circumference is equal to the pi times the diameter. But diameter here is 0.6. So 0.6 pi. And then we're going to do 0.6 pi times 779. Because that's going to be the number of, I guess, meters, right? Per minute. And then we are going to do this divided by 1,000 because we want to get it in kilometers, right? Yes, and we're in meters. So actually, we'll just, okay. So we're going to do 0.6 times pi times 779, which is this. And then we need to convert this to, so 14, whatever, and that's going to be in meters times, yeah, we're going to divide that by 1,000. So divide by 1, 2, 3, to get kilos. So that's 1.46. Okay. To the nearest kilometer per hour. So I'm going to say 1 point, oh wait. What is the approximate speed to the nearest kilo per hour when it's showing 779? So it's going to be 1. Doesn't make sense though. Okay. Maria gets new tires for her car. The radius of each old tire and the radius of each new tire is 11%. What is the circumference of each new tire? Oh man. So the radius is 11% larger, so that's 0.3 times 1.1. That's going to be 0.33. And then we want this. What is the circumference of each new tire to the nearest tenth? So the circumference is just pi times the diameter, which is 2 times this radius, which is 0.66. So times by pi. And we get this. To the nearest tenth, it says, what is the circumference of each new tire to the nearest... Oh, no. Oh, yeah. So it's about 2. No, 2.1. Nearest tenth. Oh my god, we have no time. All right, what do we have to do here? Oh, this problem. If x is not equal to -1, what is the value of... I'm just not getting it. So this is going to be 2 over x plus 1, right? Plus 2x over x plus 1. So that's 2x plus 2 over x plus 1, which is just 2x plus 2, negative 1, 0, 1. I don't know what I'm doing, though. I don't know, which is just negative 1. So 2 minus 1 is just 1, so that's x plus 1. What is the value of... I really don't know. Maybe I'll go back to this problem up here. Another convenience store in the same state sells a 4-pack of AA batteries for $4.89. Okay. If the store's price is more than predicted by the line of best fit, so it's about $49. Predicted by the line of best fit, sure. What is the least number of competitors a store could have? It's 1. Time's up. All right, time's up. Let's go ahead and check our answers. Let's see how we did, because I have no idea how we did here. I'm going to pull it up real quick. Where did I get this test? Oh yeah, okay. Let's see. Oh, we didn't do this one? There's no way. Dang. Alright, well, we missed probably one. That really sucks. College Board's official practice tests. I thought we got all of them. I must have forgot to go back to that one. Oh well. This is April 2017, school day, full test. Oh wait, no. We don't want full test, we want answers. Let's see how we did. What are the answers? Oh. All right, let's see. C, A, D, C, C, D, A, B, B. Okay. C, A, B. Oops. There you go. DD. Okay. I was about to say. I thought I missed 18. 18 is right. 19 is D. 20. Wow, missed 26. That sucks. Yeah, that was a really weird question. I'm not really sure what they were asking, to be honest. I'll have to go back and take a look. Not sure what to say there. 27's right, though. 28, obviously, we didn't get to. Wow, we missed a lot on this one. That was bad. 29 is A. D. What, dude? Apparently they're saying this is 2. I don't know. I'm not sure about that. 65. Nope. And it is 2.1. Wow. That was very bad. I'm not sure what happened here. So they're saying this answer was C. Let me take a look. Another convenience store in the same state sells another pack for $4.89. Okay. If the store's price is more than that predicted, what is the least number of competitors the store could have? Why is it C? I don't get it. Yeah, I don't know. If the store's price is more than the predicted by the lineup. So, 49, again, around here. It's about there. What is the least number of competitors the store could have? I guess they're saying it's 3. I'm not sure why, but all right. And then this one was, whoa. This one was just a trig kind of problem, I guess. I think they wanted you to say, oh, well, this is 5, this is 5. Then you can go ahead and calculate this side using trig and this side using trig. Find the area of the whole thing, and then multiply for this one as well. This might be 3 and 4. Might be. Something like that. All these were right. And then this one they said is 2. Honestly, I'm not sure. Maybe I just was being stupid, but I don't know why it's saying it's 2. So if x does not equal -1, what is the value of all this? X does not equal -1. Okay, so 1 over 1, if we plugged in 0, times 2 equals 2. Okay, how about if I plugged in 3? So it'd be 1 over 4 times 2 plus 6. Oh, it is. It's 2 every time, no matter what. Because then it'd be 8 times over 4, which is 2. Man, that was easy. And then this one, I'm not sure what happened here. Radius on each. Okay, so the circumference would be pi times 0.6. 779. Oh, I see. I did the wrong calculation. I accidentally did. I didn't understand that they said per hour. They were looking for a speed. Yeah. It would have basically just been distance equals rate times time kind of thing. And then find the rate. All right. I'm okay with that, I guess. Is what it is. All right. I am going to end the stream. And I gotta go. So I will see you guys later. But thank you guys for watching.